What if I told you that there's a breakthrough in AI that's happening quietly and behind the scenes? Far from the hype of chatbots, avatars, agentic AI, ChatGPT-5, what if the next big leap in enterprise AI isn't about making text sound more human, but finally unlocking the real power of structured data that's sitting across your CRM, across your finance systems and data warehouses? Well, today I'm joined by the CEO of a company called Kumo. And my guest today previously held CTO roles at Pinterest, Airbnb Homes, and he's known for scaling some of the most data-driven platforms on the planet. But now he's tackling a very different kind of complexity. The relational data that quietly runs the world's businesses, but is rarely invited into the AI conversation. So my guest is going to tell me a little bit more about Kumo's Relational Foundation Model, RFM for short, how that is turning the traditional model building process on its head. I mean, try to imagine building 60 predictive models in just 2 weeks instead of spending over a year, and you'll have a pretty good idea of where we're heading. So we'll talk about why feature engineering is fading somewhat and how synthetic data has become the secret sauce behind their breakthrough, and why enterprise AI must do more than just look clever. It has to deliver outcomes that matter. So if you've ever wondered why LLMs struggle with tabular data or how to build AI that actually understands your business, there should be lots for you in this conversation. But enough from me. Let me officially introduce you to my guest. So thank you so much for joining me on the podcast today. We last spoke last year, but can you just remind everyone listening with a little about who you are and what you do?
So hi, everybody. I'm Vanja Józefowski. I'm CEO at Kumo.ai. We've been working on this for the last 4 years almost. Before that, I kind of went from a research career in places like Yahoo Research and Google Research and working mostly on the technical things, then to being an entrepreneur, having a company previously that got acquired by Pinterest, and then being a CTO at Pinterest up to the IPO, and then CTO at Airbnb Homes through the IPO as well. And I'm back to being an entrepreneur and technologist.
And I've got to ask, I mean, you've held CTO roles at Airbnb, Pinterest, been around so much. What led you to launch Kumo? What problem were you most compelled to solve in enterprise AI? There's got to be a story there, right?
Yeah, I mean, I've been to and various different companies through the valley. I've been fortunate to be in the Silicon Valley at a time of great change and great technological change and throughout it in different roles. But I think if you can kind of describe my 2.5 decades of career simply, is that I've worked on helping companies store and use enterprise data to improve their businesses, to improve the service for their customers. And so with that journey, and we just discussed, I'm here at the conference, which has been around for 20 years, called, in data mining. In that journey, we went through many iterations of how do we extract value from the data. But what's really important is this data is used to predict the future, is to predict the preferences for customers and so on. And although we have so much advances in AI, dealing with enterprise data has not changed a lot in the last 2 decades that I've been working on. And so with Kumo, we decided to go and be very ambitious and try to use the newest in AI technology to radically simplify and change getting value out of enterprise data.
And I think it's worth raising here that structured business data, that is the magic that powers day-to-day operations. And yeah, it is often left behind in some of those AI discussions where people just get obsessed with this shiny technology, not the data that brings it to life. So why do you think this part of the data landscape has been overlooked for so long? Because as you said, the conference is 20 years. This is not new, is it?
Yeah, I think, and again, looking through the history of technology, I think relational databases were the first successful software business at scale. And there's a reason for it. The reason for it is that relational data is the natural match for a data you would capture in an enterprise, because you have entities or dimensions and you have facts, which are events, right? And so I think that industry scaled and kind of then spawned everything else. But the problem with this data is just it's messier than image and text. Images are simple matrices in some ways, and some of the key innovations like convolutions at core are very simple. It's a sliding window over the image, basically to featureize the pixels. Text is a simple string. Dealing with data in multiple different tables, with timestamps, with many different types of columns, strings, numbers, floats, everything is just a lot harder. It's not that simple, and that's why it has been left behind.
And Kumo RFM is described as the first foundation model for relational data. So just to bring that to life, can you walk me through how it works and what it is that makes it different from traditional predictive models out there?
Yeah. So if we look at how traditional machine learning or modeling has been done, it basically you have to anticipate in advance. What do you want to predict? Predictions drive decisions. Enterprises are built on decision making. Micro decisions like what will I show you today if you come to purchase, or macro decisions like which area I need to invest. All of these decisions are based on the data that you have. And so traditionally, you would understand what you need to predict. For example, I need to predict what people buy, and then I'll build a recommender system model that will require data engineers, data scientists to work for months to get this model out. I think, to contrast that with how we used to do that the same with text and images, before large language models, you would focus on a certain task like document classification, you will solve that. And then large language models, what they brought this task-agnostic, zero-shot kind of thinking. You don't build a specific model for document classification. You build one model that can do all these tasks. The same way Kumo RFM is a one model for any predictive task in the enterprise. And it's pre-trained as well as the large language models. It's not only trained on your enterprise data, but it comes pre-trained on a large number. You can think of it as a large number of public and synthetic data warehouses that we have created. And then it's allowed you to kind of ask a question to your data and get a predictions without having to build a task-specific model, without having to go through months of work to build that model and then years to improve the performance of the model. And that's where I think the real breakthrough is coming, finally, to enterprise data.
And I was reading before you joined me on the podcast today that you have also said that it can deliver predictions like churn or fraud detection with zero-shot accuracy. So what does that mean in practical terms for that business leader listening who's maybe using legacy data systems, for example? What does that mean to them?
I think that's where it's in many ways mind-boggling. Even for us, it took a while to digest what we are seeing and kind of push forward into that route, because there's many different ways we could have built them. We could have built a vertical kind of foundation model for churn only or fraud only, but it seems like the technology kind of showed us a way that it's possible to have something that works across many different problems. I think, again, to make an analogy with large language models, because I think most people are much more familiar with those, you can use it directly as is. And in this way, you will get responses instantaneously, and those responses will be great. They'll be on par with what, in most cases, what we have tested when, with models that are built in a traditional way. Now, you can also fine-tune this model the same way as you would fine-tune large language models. And in that way, you use the entirety of your data. Because when we do zero shot, we do in-context learning, we grab a piece of the data, but it doesn't use the entirety of the data. If you fine-tune the model, you'll use the entirety of your data, and you will get better performance, 15, 20% sometimes. And we have also designed fine-tuning technology that actually shrinks the model, you know, and with that makes the model cheaper to apply in production. Because in enterprise use cases, often when we build models for specific task, we apply these models at very high QPS, 10,000 QPS in some cases when you do ad serving, and so the cost of serving is a substantial parameter here. So we had to adapt our technology to fit well into the enterprise context and make it cheap enough and versatile enough to be able to run in production. So what does this mean? You can start things very quickly. You can cut cost of having to build and maintain multiple models. In one of my prior employments, I had 430 models in production, and that means 430 pipelines to maintain and build and make sure that some of them are not silently breaking and then declining over time. You can get things going really quick and you don't have to anticipate what kind of business problem you want to make decisions on. So it simplifies the whole business. And I think every time you have such a technology that changes things radically, I think it's going to take a little bit for it to ripple through the technical stack in the enterprises. But I think it's going to be an amazing simplification and unlock to get more value out of your enterprise data.
And many AI teams still spend huge amounts of time on things like feature engineering. And I was reading that Kumo can eliminate or automate that process. So tell me more about that and what that unlocks for developers and data teams too, because it feels like a big moment.
Yeah, feature engineering is basically, and in general, I think there's this impedance mismatch between data in multiple tables. This is how we invented to store and capture data about enterprises. And then when you train a model, you use optimization framework that require a single table, which is called a training table. It has training examples. Each training example is composed of features and a label. Now, the features is basically manually human intuition of how to construct signals that correlate with the outcome or are predictive of the outcome. And this is what we have been doing, I don't know, since the 90s. This is what we did in regression. We'll find the right regressors and then we will build a function on the top. And so eliminating this step eliminates the need for a human to be in the loop and able to find where the signal is. And this is the journey that, for example, computer vision went 20 years back. We used to find manual features in images, that's edges, and then would use those for, say, image classification. I wrote code like that about 20 years back at Yahoo. And so today, it just goes straight from the raw pixels all the way to prediction. So and the benefits of going straight from the raw data is that you're simply learning over the entirety of the data because the features is just the summary statistics of the original data. Those edges we were using in computer vision, they would use only pixels under those edges. And so when you use the entirety of the image, when you use the entirety of your relational data warehouse to predict, you get much better performance at much, much simpler. And this is a transition that I think is going to be remarkable in getting better performance a lot quicker for models in production. And we see that. We get double digits model improvement with customers who are very sophisticated, have trained models for almost a decade. And the yearly improvement will go in the range of 1% to 3%. As once you're getting 20, 30% because you're learning on the entirety of the data.
And throughout your career, you must have seen so many big changes. And over the last few years, there's been so much hype around large language models. We've all seen that. But how do you see models like Kumo RFM, for example, complementing or maybe even contrasting with that LLM revolution and narrative that we see on our news feeds? Anything you can share around that?
I think the advances have been just astounding. Like I could have not predicted this for sure. Although I've been in the industry and in the companies where some of these inventions happen, or maybe I was on a conservative side. But Kumo's modeling technology is specifically for enterprise data. This is a problem that large language models do not solve today. You can try to ask, first, they would not be able to ingest. You can throw in all the tables of a data warehouse in a prompt. You will have to textify it and so on. You might get back some answers. People have tried this, and it's bad. I mean, the accuracy and similar metrics is in the 50-60%, while pre-trained machine learning model might, same data go in the 90%. So it's not a small difference; it's a huge difference here. Kumo is complementary to large language models. At some intuitive level, a large language model have human-like reasoning, and humans are not good with dealing with a large number of textual tabular data. And so the same way that humans use Kumo to build better models and easy to build models easier, large language models will use Kumo to get predictions instantaneously from the data. So instead of the large language models having to, write code, train models, and so on, or do analytics and then hallucinate on the top, here, we have MCP server in Kumo. You can call and ask any predictive question, and you get instantaneous answer. So Kumo is basically a fundamental part of the agentic toolbox that large language models would use for tasks that they're not suitable in doing, the same way that RAG and other technologies are.
And before you joined me on the podcast today, I was also reading that you trained Kumo entirely on synthetic data. So I'm curious, why did you choose that path, and how do you ensure that predictions are relevant for real world business scenarios? I feel there's got a bit of a story there too, right?
Yeah. What I would say is, like, we built the Kumo platform, and with that we adapted transformers and attention mechanism for tabular relational data. And then we use this platform to build a foundation model. And building the foundation model is like cooking a soup. The platform is maybe a stove, right? You build a stove. Now you can have the right temperature for the soup. But when you cook the soup, you need to get the right ingredients, right? And that's where the training data comes in. And the mixture of the right ingredients is really what defines the capabilities of the model. And so we started with public data sets, and that's we amassed as many as we can. But public data sets get you just so far. You don't have control over them, right? People put what people put out there. Some of them are too clean, like most of the Kaggle data sets, a single table cleaned up, featureized already, right? And so we were kind of got into that level of stuck a little bit, that we needed more data. We just could not really find out more public data. And so then we started mutating public data. And that mutation allows us to have a full control over, what kind of data it is in some ways, while but on the other hand, something grounded in reality, and created orders of magnitude more synthetic data. And found that it was just so much easier than if we have a gap, having to go around and scramble to find the right public data set that will cover that gap. So I think synthetic data gives you, and probably for large language models too, it's like they give you the power to decide where to go. And that's why it was quicker for us to figure out the right ingredients of the soup so it tastes right.
What a great analogy. Love that. And of course, AI projects are notoriously expensive. We're seeing many businesses focus on ROI this year, quite rightly so. So when enterprise AI focuses on things like real transactions, real outcomes like revenue, retention, or fraud, what kind of ROI are you seeing from your customers that are using Kumo? Because it is a big focus right now, and I'd love to hear some of the stories that are coming out of this.
This is actually the highlight of our experience with customers, is when we launch a model. Let's say for a customer, we do a notification, you launch a model and you get a 30% improvement, and you get hundreds of thousands of more monthly users, where people didn't think this was possible at all. it's like moving the MAUs for a company is extremely hard, because you have to, if you're giving recommendations to people, to get an instantaneous reaction, it's one thing, but to give them something so good that they come back again, that's the whole different level of difficulty. And we see this type of results. And a lot of our customers are some of the most sophisticated companies in the Silicon Valley. So this is not just going in and telling people how great our technology is, and then the door opens. These are places where things are rigorously tested, and these problems that we are solving have direct impact on revenue. So if it doesn't work, it's very quickly noticed by the CFO in the bank. So I think this is where it's really exciting to work with this type of technology, when you see that aha moment, when you see those kind of significant benefits, and secondly, when people see how fast they can make these models. It's like we had another customer saying, wow, I built 60 models in 2 weeks, and this would have taken me over a year without this platform. And so those are the type of things that new technologies bring, and it's like, that's why I'm doing this job, because it's so exciting to see those results.
Well, thank you so much for talking about this in a language everyone can understand, and sharing your insights and the great work that you're doing. But before I let you go, I'm going to ask you to leave one final gift for everyone listening, and that is either a song that we can add to our Spotify playlist, or a book that you'd recommend for our Amazon wish list. I don't mind which, but what would you like to leave everyone with, and why?
Well, since you're coming from Britain, I'll choose a British author. It's a book that inspired me when I was younger, but also I must say it was a book that my son picked up in during Corona, and inspired him to become an avid reader. And he's actually just now, as we speak, doing his LSAT exam for his law school, and good luck to him. But the book is George Orwell's biographical book, which is called Homage to Catalonia, which describes his experiences in the Spanish Civil War. And I would recommend it because it shows what conviction can bring. It also shows how, if you have a critical eye and critical mind, when you see things that are not working, you can call them out. It shows how, that stoic response that maybe Brits have a little more than all of us in things of adversity. He gets, heavily, dangerously injured. He writes 2 sentences about it. So it's a general, I think, a book that describes the world as is, and from one of the best authors in the history. So
Wow, what a great choice. I will get that added to the Amazon wish list for people to check out. And also, obviously, we've talked a lot around Kumo today. For people wanting to find out a bit more information, how it might be able to give them that elusive ROI from AI, where would you like to point them?
yeah, please visit us at our website, kumo.ai. We have now Kumo RFM, so kumorfm.ai as well, where we have a sandbox with preloaded dataset with an e-commerce kind of a scenario, where you can write queries yourself, you can predict sales of products, you can predict recommendations for customers and all of that, and see how it works. We have also enabled that you can upload your own data, and it's very simple. It's pandas, data frames, you upload it there. And then you can build a very, very simple notebook, literally half an hour, and answer predictive questions from your own data. And if you have models in-house, you can see how quickly you can get the predictions, and you can compare the quality of the predictions with the predictions you have. And please, we would love to have you try the product and give us feedback and understand us how we can make this easier. Yeah, very excited.
Awesome. Well, I would add links to everything so people can find that. And it's such important work you're doing here, especially right now, because while most conversations are focusing on LLMs and chatbots and agents, I love how you're addressing a very different challenge, a very important challenge, those vast amounts of structured business data that consist of transactions, customers, inventory that remain trapped in outdated legacy systems. So much more we could talk about this, but just thank you for highlighting it today. Really appreciate your time.
Thank you, Neil. Have a great afternoon. It was great being here on the podcast. Thanks for having me.
What stood out most to you in that conversation today? For me, it was that simplicity is hiding behind the complexity, and how Kumo is making enterprise AI feel a lot less like alchemy and more like plug-and-play prediction. And I think it's a refreshing reminder that not all innovation lives in the glow of generative AI. Sometimes it's quietly solving the hardest, least glamorous problems, like messy relational data and the pain of building yet another churn model from scratch. And his story reminded me that the real-world impact often happens far away from the spotlight. So whether you are a CTO juggling 400 plus models or a startup looking for just faster time to value, but what do you think? Are we underestimating the value of structured data in the AI arms race? Could tools like Kumo become that connective tissue between LLMs and enterprise systems? Love to hear your thoughts. Pop by techtalksnetwork.com to find out more information about this podcast, how you can contact me, and all that stuff. But that's it for today. So thank you for listening as always. I'll speak with you all again soon. Bye for now.